Article 408.3b of the National Electrical Code addresses the requirements for derating current-carrying conductors in situations where more than 30 such conductors are installed in a raceway cable tray or cable bus that has a cross-sectional area of 1.0 square inch or more, and are bundled in a manner that does not permit adequate dissipation of heat. The code mandates that the current carrying capacity of these conductors must be adjusted to reflect the reduced capacity. This adjustment is often referred to as derating. The primary reason for this requirement is that when current-carrying conductors are bundled together tightly, especially over significant lengths, the heat generated by each conductor can accumulate, leading to a higher overall temperature within the bundle. This increased temperature can degrade the insulation of the conductors, reduce their lifespan, and potentially create a fire hazard. Derating is a safety measure to ensure that the conductors operate within their safe temperature limits, even when bundled. The code specifies that derating is required when the bundling prevents adequate heat dissipation. This implies that if the conductors are arranged in a way that allows heat to escape, even with more than 30 conductors present, derating may not be necessary. For example, if the conductors are spaced apart from each other within the bundle, or if the bundle is loosely wrapped, allowing air circulation, the heat can dissipate more effectively. Several factors influence the need for derating. Firstly, the number of current-carrying conductors. The code specifies a threshold of more than 30 conductors. Secondly, the bundling method. Tightly bundled conductors are more prone to overheating compared to loosely arranged conductors. Thirdly, the length of the bundle. Longer bundles accumulate more heat, increasing the need for derating. Fourthly, the ambient temperature. Higher ambient temperatures reduce the heat dissipation capacity of the conductors, making derating more critical. Fifthly, the type of insulation. Different insulation materials have different temperature ratings. Conductors with lower temperature ratings may require more significant derating. Sixthly, the size of the conductors. Larger conductors generate more heat, potentially requiring more derating. In the specific scenario of more than 30 current-carrying conductors bundled over 24 inches long in a panel board, derating is generally required unless it can be demonstrated that the conductors are arranged in a way that allows for adequate heat dissipation. This demonstration might involve showing that the conductors are sufficiently spaced apart or that the bundle is loosely wrapped. To determine the appropriate derating factor, refer to the ampacity tables in the National Electrical Code, specifically Table 310.15b3. This table provides adjustment factors based on the number of current-carrying conductors in a raceway or cable. The adjustment factors are applied to the allowable ampacity of the conductors to determine the derated ampacity. For example, if you have 31 to 40 current-carrying conductors, the adjustment factor is 0.80. This means that the allowable ampacity of each conductor must be reduced by 20%. Another factor to consider is the termination temperature rating of the equipment to which the conductors are connected. Section 110.14c of the National Electrical Code specifies the requirements for conductor termination temperature. Conductors must be sized so that the ampacity based on the conductor's temperature rating is not greater than the lowest temperature rating of any connected termination conductor or device. This means that if the equipment is only rated for 60 degrees Celsius or 75 degrees Celsius, the conductors must be sized accordingly, even if they have a higher temperature rating. It is also important to consider voltage drop when sizing conductors. Voltage drop occurs when the voltage at the end of a circuit is less than the voltage at the source. Excessive voltage drop can cause equipment to malfunction or fail. The National Electrical Code recommends limiting voltage drop to 3% for feeders and 5% for branch circuits. To minimize voltage drop, use larger conductors or reduce the length of the circuit. The National Electrical Code also provides guidelines for conductor installation. Conductors must be protected from physical damage and installed in a neat and workmanlike manner. Conductors must be supported at intervals specified in the code. Conductors must be identified at each termination point. When working with electrical systems, always follow safe work practices. De-energize circuits before working on them. Use appropriate personal protective equipment, such as gloves and eye protection. Consult with a qualified electrician if you are unsure about any aspect of the work. It is crucial to understand the terminology used in the National Electrical Code. Firstly, ampacity. This is the current in amps that a conductor can carry continuously under the conditions of use without exceeding its temperature rating. Secondly, current carrying conductor. This is a conductor that carries current under normal conditions. Neutral conductors are considered current carrying conductors if they carry significant unbalanced current from nonlinear loads. Thirdly, derating. This is the reduction of the allowable ampacity of a conductor due to factors such as bundling or high ambient temperature. Fourthly, raceway. This is a channel designed to hold wires or cables. Examples include conduit, tubing, and cable trays. Fifthly, cable tray. This is a support system for cables consisting of a trough of ventilated bottom. The National Electrical Code is a comprehensive set of rules and regulations governing electrical installations. It is updated every 3 years to reflect changes in technology and best practices. It is essential for electricians, engineers, and other professionals involved in electrical work to stay up to date with the latest version of the National Electrical Code. The intent of the National Electrical Code is to provide a safe electrical installation. The National Electrical Code is not a design manual. It provides minimum requirements for safety. It is the responsibility of the designer to ensure that the electrical system meets the specific needs of the application. In summary, when dealing with bundled conductors in panel boards, a careful assessment of the number of conductors, the bundling method, the length of the bundle, the ambient temperature, and the insulation type is necessary to determine if derating is required. Always refer to the National Electrical Code and consult with a qualified electrician to ensure compliance and safety. Always verify that all work conforms to the authority having jurisdiction. Remember that electrical work can be dangerous, and it is important to take all necessary precautions to protect yourself and others. This involves understanding the National Electrical Code, using appropriate tools and equipment, and following safe work practices. By doing so, you can help ensure that electrical systems are installed and maintained safely and reliably.